Um, Good morning. Today we'll be discussing about the bra and the kit notation. So now we know what a wave function is, and a wave function is denoted by psi. So now what a wave function does in quantum mechanics is that it describes a system of interest. So when we have a quantum system that we as the observer are ignorant of the content of this quantum system. Now, what gives us the ability to be able to describe this quantum system of interest is the wave function. Take, for instance, an electron, for instance. For you to know the content of a quantum object, such as an electron, we need a wave function to describe it. Now, mathematically, a wave function is a mathematical object that gives us the ability to gauge or describe the system of interest, which is the quantum object, such as the electron. And this wave function is given as the wave function is given as A1 1 0 0 plus A2 0 1 0 plus A3 0 0 1. So now all this is a coefficient A1, A2, and A3 are complex coefficients. So now if that is the case, we all know that what Dirac does is that he is trying to look for a more simpler way of describing a wave function. So he brought about the bra and the ket. Now, assuming we have a bracket, so that we enclose it in this and we cut a line across this C in the center. So now what we have here is denoted as the bra vector, and what we have here is denoted as the kit vector. So now using this definition of a wave function, which I just defined initially, is now giving us a kit of this wave function is defined as a column vector of the complex coefficient of the wave function. And why the bra vector is equal to the rho of the complex, and not just the rho but the complex conjugate. You have to take the conjugate of the complex number. So now this is what you will get. So now it means that when we are given a wave function in the ket form as 2 plus IY, now the bra of that same vector is the same as 2 minus IY. When you are given a kit vector as 2 plus 7y. Now the ket of that same vector, the bra of that same vector will give you 2 plus 7y. Now the reason is because now in this first example, we know that when we are given the ket of this function vector as 2 plus iy. Now when you take the bra of that same vector, it's just like taking the complex conjugate, and you can't take the complex conjugate of a natural number. It must be a complex number. Now when you look, both of them are not having any imaginary term there, so therefore they still give you the same thing. But when you have 2 plus I7y, then as your ket, then when you take the bra of that same vector, then you have 2 minus I7y. So this can only work for a complex number.